Our next topic is Industry 4.0, collaborative quality management in the automotive value chain. And I'm happy to announce two speakers for this interesting spot. From Stuttgart, Mr. Michael Jochem, Director Business and Chief Digital Officer Industrial Technology at Bosch, and Mr. André Luco, Head of Emerging Technologies at BMW Group. It's a pleasure for me to hand over to you.
Carmen, thanks for the invitation and for the introduction. Good afternoon to the audience. Coming from the challenges in the automotive industry, Andre and myself present the quality management collaboration model in the automotive value chain. Andre will outline the challenges.
Yeah, thank you, Michael. I'm very happy to be here and talk a bit about our joint project together with Bosch here. So designing, building an automobile is a very complicated affair, involving many different engineering disciplines, partners, manufacturing, distribution, and sales. At the same time, the automotive industry is undergoing a rapid change toward autonomous vehicles, increased connectivity, electrified vehicles, and an increasing amount of services surrounding our vehicles. At the same time, that means the complexity of our product is increasing. We have more software, more services, more variants. The BMW Group is orchestrating an international value chain comprising of more than 31 manufacturing locations around the planet. We produce 10,000 vehicles per day, and for those 10,000 vehicles, we have to move 31 million parts from 4,500 partners around the globe. In order to do so, we are still currently hampered a bit by the progress of digitization, right? Because we still use IT like 20 years ago, just we don't use paper, we use now spreadsheets and emails. We believe, right, using data-driven technologies, using Gaiax-based building blocks, we can improve the efficiency of our value chain significantly. And what we are going to do, I hand over back to Michael.
Thank you very much. Have a look at today's quality management process. This is purely driven by complaints reported to the workshops. Malfunction occurs, the vehicle goes to the workshop. Workshop diagnosis, vehicle, decision is made, what part is responsible for the malfunction. Part is replaced. Out of the so-called reference market, a small percentage of complaint parts are sent to the OEMs and subsequently to the supplier for investigation. And be aware, the reference market for German OEMs is typically Germany, and for French OEM, it is typically France. This means, for example, if a problem is predominantly occurring in hot countries, it might take a while to get to the attention of the German OEMs. Today, the data is kept in proprietary systems. Only small bits of information are shared with the supplier in case of a claim. A context information such as what triggered the failure, what happened in the vehicle before the malfunction occurred, is not available to the investigation team. Hence, wrong conclusion can be drawn by the team or root causes cannot be found. 50% of the replaced parts are the so-called TNF, trouble not found. Means the part is found according to the specification after the investigation at the supplier. This information is not feedback to the workshops to report the future repairs and avoid unnecessary replacements. As I said at the beginning, a new unknown failure needs to occur in the reference market. It needs to find its way into the random sample that is sent for investigation. This is the way where the new failure mode gets to the attention of the OEM and the supplier. The time between the first occurrence and the detection can easily be longer than 6 months. The random sample concept also leads to an inefficient complaint process. 80% of the complaint parts which are shipped to the OEM and subsequently also to the suppliers do not add value to quality. It blocks the parts pipeline at the investigation point, but are failure modes which are already understood and fixes are already in place. So how can we do all this better? We need a shift from the traditional quality management to a data-driven collaborative quality management to face the pains. In fact, all data is already available today. Having a collaboration model, as you can see on this slide, we can use the available data to shorten the time between the first occurrence of a malfunction and the identification of the root cause. Let's look at the data which is already available today. The first shown business case, early warning, offers a massive benefit. We take the vehicle diagnostic trouble codes, combine this with the ECO default path, take into account the data patterns already known from failures, and add trend detection algorithms. As a result, we can detect emergent failures in the worldwide vehicle populations 6 months earlier. This results to a 20% reduction of external failure cost of the OEM and suppliers. The next example reduces the number of unsuccessful repair trials significantly. This slide shows also 2 further examples for the value of the data-driven quality management. The data-driven warranty decision allows a warranty decision based on data and reduce unnecessary part shipment and investigation by 80%. The last example is an effective and efficient root cause analysis. This helps the investigation team to understand the failure mechanism by comparing vehicles in which the failure was present with those vehicles which never had the failure. So what do we need for this? To organize the described collaboration and increase the benefits for all involved participants in the chain, we need a framework which covers the interests and requirements of all the participants. Data is sensitive and it cannot be shared from everybody to everybody. It needs to have a service framework based on a trusted platform with clear rules and transparency. This slide shows the trusted platform in more detail. The trusted platform has to provide data access control mechanism to take into account the interests of all and the sensitivity of the shared data. Based on defined rules, advanced services can offer the described benefits shown in the business cases examples on the previous slides. The data remains in possession of the respective owner and data access layer is under control of a trustee. So how do we bring this to Gaia X? This described framework shows indeed the necessity of a federated and decentralized infrastructure with policy, rules, and a sovereign data exchange. So Gaia X provides the capabilities for a multilateral data exchange of many participants as a prerequisite to scale the collaborative quality management. The question is, how can this framework be integrated within Gaia X? The slide shows necessary building blocks for Gaia X, and the previously shown trusted platform with the data layer, the data access control, and the service layer has to be located and integrated within the Gaia X architecture. There's place for this to do this. Mainly the data access control mechanism will become part of the Gaia X Federation services combined with additional decentralized services, and data can be hosted on any cloud or on-premise. Essential in this topic is the seamless availability of the data during the complete life cycle, as you can see on this area of the slide. So we need a seamless availability of the data for the complete life cycle of the vehicles, including the data during the production and the data during the usage of the vehicles. This means the industrial world need to be combined with the user world. For the next slide, I would like to hand over to Andre for the conclusion. Thank you very much.
Oh, yeah. I think this example very much showed data sharing is the key for innovation, right? So far, we have been hampered in our innovation by our ability to really share the data effectively. We believe with the Gaiax building blocks, the federation service, we really can ad hoc collaborate and share data. And data gets better if it's shared, if it's connected. Bosch, on their side, they can draw their conclusion by getting some insights on how we see a data point about their part in the field. We get much more value because we get the issues earlier resolved and we make our customers happy. So this is a really true collaboration. And overall, this is just the starting point, because obviously we do not just want this to be a BMW and Bosch story. We want this to be something bigger, right? A network gets better the more participants are involved, the more data gets shared, and at the end we are just getting this thing started. One key thing here is, and that's what we are also going to explore in our shared project, is the idea of co-petition, right? We want to have a shared platform for the comment of everyone who contributes to that platform, but we also want to enable innovation, right? So there needs to be the room for competition to get an innovative edge. And we are working very hard, right, on ideas to really make this platform happen in the Gaiax ecosystem. Thank you very much for your attention.
Thank you for this interesting presentation, Mr. Jochem and Mr. Luko.